Okay, everybody. So today we're gonna go into Rust fundamental one. Okay. All right. So why Rust? Rust is very memory efficient. Rust is simple. Yeah, especially for those that came from the TypeScript background and JavaScript. Maybe Rust is quite easy, yeah, to grasp, right? Yeah, the only issue you may have is understanding memory, heap allocations, and stuff like that, right? But trust me, it's absolutely simple. So we're going to talk about uh, memory. We're going to talk about we're going to talk about ownership, memory management, just a few stuff, right? Just shallow. We're not going to go deep today, yeah. And basic syntax and data types and stuff. So um, let's pull up terminal. So first we need to create a Rust project. We go cargo new and then Rust fundamentals. Now what is cargo? Cargo is the Rust package manager. Now you have npm in Node.js, TypeScript, JavaScript. Yeah. So the equivalent is Node and pip, which is pip Python installation package for Python. So same thing on Rust. We have cargo. And then we cd or navigate into the directory. Let's pull out the folder and go. So what do we have? We have init.rs. So we always build. It is conventional um, to build your code before you run the code. So cargo build, and then we can run it. Cargo run, we expect hello world. Well, does it look very fast? I mean, Rust is an absolute beast. Yeah. So basically, you can do this. You can run this command and this at the same time by doing cargo run build. So it will build and then run it, right? So very simple. Okay, let's go into our code. I'll just pump this control plus. Let's just clear it up. Let me see. Okay. This looks good. I think, yeah. All right. So the println, this is a print statement, just as we have print hello world in Python, and we have console.log in JavaScript or TypeScript and C. I know that. Yeah, Java. I mean, there is a lot. So from any background, C++, C, Java, whatever, we it is similar, right? Okay, so let us talk about ownership. So let's say Mamankechi has a basket of tomatoes, and then Adamo comes to the market and pays for that basket. All right. So Mamankechi's basket will be passed to Adamu. So Adamu now owns uh, the string. He now owns this basket of tomatoes, right? So this is called most semantics in Rust. Is a way of making sure that notables on um, one variable or or same data, right? So we can only have one owner, and then any other is a reference or a borrow, right? So let's speak about borrow. Um, so just in case you have a friend and he got some nice slides, and you want to go to a party and you need these slides, well, you don't want to buy basically, or maybe not enough to enough budgeted for that. So you can meet your friend. Hey, bro, can you get me your slides? I just want to use it. I want to return it. So what happens is you are using that. People see with it, but it is not yours. It doesn't belong to you. Your friend is still the owner. So we can reference this data here, and this basket of tomatoes still belongs to Mamankechi, but Adamu is just borrowing it for a moment, right? He doesn't own it. So Adamu does not own the data. Yeah. Basket of tomatoes. Yeah, he doesn't own it anymore because he is borrowing. Um he's just referencing that. Yeah. Okay. Let's comment that out and then move on to the next, which is basic syntax. We let's say basic syntax. Now let's define a variable score equals to 10. Now the let is used to initiate a variable score, and this mute here is used to make this variable here changeable or mutable. I mean, if you watch Mutant Ninja Turtle, see that they change. So the reason why they're called mutants is because it can change. So mute here is meant to make this changeable, so you can update the value of this. You can update the value of this, right? You can do score equals to 20, right? It is mutable. Okay, let's print this and see. Remember, you can do cargo build before cargo run, but you can equally do cargo run build, and it does that. All right, so here we are. Boom. These are warnings. These are warnings, right? You can get rid of it. Sometimes you can escape it. That is Rust for you. I always escape. Yeah. Okay, so we also have data types. We got a lot of data types in Rust primitives, and one thing that fascinates me is number. There are a lot of numbers, and you have to specify each, whether it is a decimal floating point, um, signed or unsigned. I mean, you have to define all of that. So let uh, name. Okay, so this is a data type string slice. This is not heap allocated. Uh, you'll go deep into that later on. Let's use G. All right, so string slice or string leader. Okay, let's say height. Height. Okay, let height. This should be F32. We have a lot. We have F64. I mean, yeah, you can actually look that up, right? Let's say 6.2. This is floating point, 22 bits. Yeah. Unless we also have age and the data type here is U8. Now this is byte basically in this an 8 bits unsigned integer. This cannot have minus, this cannot have negatives, right? You're gonna see a lot of this in Anchor when we start hitting Anchor, you're gonna see a lot of it, right? So uh, and basically we have EU64. Yeah, we have them. We also have EU64, and let's we have Boolean. Let a student bool equals to okay Boolean. So Boolean is kind of like checking a if something is true or not. True or false, basically. Yeah. Yeah. So a student, we're talking about Mamankechi here. She's not a student, obviously, right? So we do false. Okay. Okay, we're done. String literal, done. F32, done U8 unsigned. Okay. Think we have signed. Let account balance. All right. So this is signed. It can have negatives, minus. You can see the minus here, right? So if you want to use negative, you just go use this. Unsigned, and also we have memory allocated string. Oh my God, I love Copilot. I love Copilot. Yeah, school. No, let's use business. Yeah, business name. Okay. Mamankechi store. She's business store. All right, so this is heap allocated. Like I told you, we aren't gonna go deep today, but this. So this is actually an object, right? There are some functions, there are some methods to it, right? So we are actually gonna touch it later on. Okay, so why do we even have to infer this? I mean, in Python, you don't need to do this; it will automatically infer. But for us, I mean, things like this actually make it more efficient. It needs to know at compile time the particular um, type of data you want to use at different places, right? Or at different points in your code. This will help prevent bad data later on, right? And I mean, it will make your code safer when you set up things like this. I know this by experience from Python, writing code without inferring the types. Sometimes I come back months later on and I have no idea what is supposed to be there. Yeah, so it is really not good, right? So you have to infer types. All right, so Ross is statically typed. It is a strict headmaster. So know that. So control flow. Let me comment this out and let's. Oh, okay, so when you're out here, right, and you want to go, you want to indent, you can just hit tab and you'll be right there. Control flow. So, what is control flow? It is a way of defining movement in operation, right? So you say, do this. If you want to prepare semo, you have to boil the water, you have to mix the semo in cold water, and then you pour the mixture into, I mean, you just do this. And then if the water is not hot, you have to increase the temperature, you know. Yeah. And basically just a sort of it if this, then you should do this. If this is so, then you should do this. I mean, you get, so that is basically control flow in our code. Let me give another illustration. So let's say I want to tell you open, how to switch on a car. And let's go over here. Let's go over here. And we go open the door of the car, get inside the car. Next, insert your key and turn right. Right. And lastly, your car is on. So let's have these arrows here. Okay, okay. Give me a sec. Let me. Oh wow, massive arrow. Go there, arrow. And then we have this. So if um if you come to open this door now, and then the door is not open, it is locked up with a key, then it means you have to do something. That's where the if statement comes in. We have here that if door is locked, insert key in handle and turn right. Okay, so this is what we want to do. So if the door is locked, then we want to do something else. We want to go here, right, and open this door before we get inside. Now this is an if statement. This is an if statement, right? I will have here. So if this door is locked, then we have to insert the key in the handle and turn right to open before we get in. And then we set our key and turn right, and the car is on, basically. So I mean, this is not the standard way of showing the flow control and stuff like this, but I mean, just so you understand the basics, right? So let's get back into the code. All right, so let's use uh, scenario ATM withdrawal scenario. Yeah, so let's say the account is mutable. Yeah, because your account balance can change. Account balance is, let's say, is equals to 10,000. Turn 1, 2, 3. Okay. And then we have withdrawal amount. Let's do $1,000. And now we want to check if the account balance is greater than the withdrawal amount. We want to allow the user to withdraw, right? So we print you've just withdrawn this amount, right? But then if that amount is if the account balance is less than the withdrawal amount, then we want to say you have insufficient funds, right? So it is very important that you write comments. Mhm. So if account balance is less is greater than first, okay, it's greater. We're not doing equal to. It's greater than uh, draw amount. Okay, draw else return. No, we want to print else print insufficient funds. Okay, so let's do if account balance account balance is greater than the withdrawal amount. We want to print. We're not changing anything. We just want to showcase the flow control, right? We don't want to add a lot of things. So you just withdrew uh, flow, and then we add some form of formatting here so that we'll be able to print this the right way to add formatting, right? Like you have in Python, you have print, and then you have this, and then you okay, you have you put F formatted string, which means formatted strings, and then you have hey, and you just withdraw this and you put this right. So the magic here is F, right? In Python, that's how you do it, and you also have a JavaScript, you have console. I'm just taking time to explain it. So, okay, so you have something like this, and sometimes you do this, to format it, right? So, we want to print that, and else, right? If it is any other condition, we want to print insufficient funds. I mean, there is so much you can do with this whole flow, but I also want to be very, 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 very basic. So if the account balance is greater than the withdrawal amount, we want to accept the withdrawal and say, hey, you just withdrew this amount. Let's put the dollar here to make it beautiful. Okay. Else, we want to say, hey, you got insufficient funds, right? So let's run our code. Okay, this is bumped also. Let me bump it again. Okay, looks good. So let's clear this. I just do CLEAR to clear the terminal. Run. All right. Yeah, warnings. You can always dodge this. I mean, so we have he just withdrew $1,000. So we just control this flow, right? Make sure it goes in the route that we want. So let's see if the second condition holds true. Right, so 10, let's say $60,000, and let's run it. Ignore this, right? Yeah, I don't advise you you ignore warnings in your program because you're actually dealing with money, right? So you shouldn't be ignoring us. But for today, let's ignore these things. So we have insufficient funds. So it means our control flow works perfectly. Okay, so next up we have Iterated loops. No, 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 no. Okay. All right, loops. Yeah, loops is next. So what is a loop? We do we brush every day, we eat every day, um you take your bath, you have a shower every day. That is a loop because you're doing it consistently at different intervals. Um, so anything you basically repeat, you're actually having a loop. You're actually doing something in a loop, right? Um, you can sometimes have a loop at definite times, or it can be random times. Like like you get into work, uh, it's not possible that you get to work the same minute, the same second every time, right? But you do it every day, basically. Yeah, so it is actually a loop, right? And we can also see loop in this context. So you have um, a bank of names or a database of names, and then you want to check the position, like in the school, right? So they are arranged according to their positions, according to their performance, first, second, third, fifth, sixth, blah blah blah. And then you want to find out what position your friend Peter is, and then there is a search box, and you input the name Peter, and you click search. So what this does is, I'm just giving you this very simple model, right? It goes to the first position, and then it tries to match the name with Peter. If it is not the same, then it moves to the second. It matches the name with Peter. If it is not the same, maybe it does that for like for like four times, and then it gets to the fifth position, and then it matches that name with Peter, and then they are same. So it now returns, hey, I found Peter at position five, at index four, position five, right? And yeah, I said index four because like it actually starts from zero, blah blah blah. I don't want to confuse it with that, right? That's for another time. But it now finds Peter at position five. So it returns that hey, Peter is number five on the board, right? So it does that with it does the matching with the first one, second, third, fourth, and then the fifth. That is a loop because it is doing the same thing with each time he tries to, right? So you can actually traverse through a list using a loop. You can do tasks repeatedly using a loop, right? So we have four loops. We have Y, and we have a loop. The Ross. I do believe that this is meant to. I mean, there's a lot in Ross when you see a normal method, right? It is not just normal. If you go to the building blocks of it, you discover some massive architecture to make it so very memory efficient. And that's why I love Rust. Yeah, so let's do an example with Mamankechi store. So let's say let mute store equals to, oh, let's use five, which is quite small. So no, not store. Let's use stock. So Mamankechi has um, five items in stock. So she wants to sell these items, right? So she's doing the same thing, basically selling. So she does it one, two, three, four. That is a loop already. So basically, let's use a while loop here. So we want to do a condition. Sorry, remember always put comments. So if as long as stock is greater than zero, keep selling. So if stock is greater than zero, it means we have at least one stock. It means we have at least something to sell, right? So we're gonna do that, right? So Copilot. This open after this. It's not completely correct. Let's do this here. Print Okay. Sorry, out of stock. Out of stock. Okay, like this. Yeah. If we do this before we do this, it means uh we won't be able to print here selling item stock left. Okay, so if we print this before we do this, then it means the logic will be broken because we print 5. What we want to do is when we sell, we want to print that this has been reduced because when you sell the first time, you have 4 items left, not 5, right? So we're going to move this line. Okay. Uh, okay. Basically, let me allow this to run so that you get what I'm saying, right? Let's see. So what this does is minus equals to is we are decrementing the stock here. Remember, this is mutable, it means it can change. We're decrementing by 1. So if you want to increment it like add, right, you can do plus equals to and into. So if we here we want to subtract 1 from it to simulate that we are selling and then the stock is going there. Yeah. Let's run this. How to run build. Oh, yeah, got an error. Oh, shit. Forget this. Yeah, exclamation mark. Let's clear it and go. All right, so see, the last talk is 1, and then it says, sorry, out of stock. But this is supposed to be 0 for you to go out of stock, right? Now our code is correct, but we placed something in the wrong place because we sold the first time, right? Selling item. Stock left is supposed to be 4 and not 5, right? That's what I was saying here, that we have to move this line above so that once we sell it, we decrement and we print this. It's kind of like pushing out an event that, oh, this has happened. So now you see, we get it to 0 and it says, sorry, out of stock. All right. Okay, so error handling, error. So error handling, if Mamankechi orders for some items from a company and then they bring some bad items, right? She's expected to do something. Basically, she can refund. She can ask for a refund or push back the products, and then they replace them with better ones, with good ones, right? All those action is hard, handling the error, taking an action that okay, so because this is the issue, then I do this to solve that problem, right? Um, so basically, error handling is a way um, of making provision for exceptions, right? That if something goes wrong, then this will happen. It's either you report, which is like returning the error message using this macro error like this, and then the message inside. Okay, message basically. So yeah, so this is same as Mamankechi having an MD, and then the MD is coming to report to her, the sole proprietor of the business, that hey, this is the problem, this is what is going on, right? So what do we do? So this error is kind of returning that, and then she now makes a decision that okay, that since this is the case, then let's do this. So this is like saying, then let's do what is here, what is on the, You can say, hey, let's make a report, and stuff. All right. Okay, so let's use a function. Let us create a prototype for checking homework. Check homework. Okay, and it's gonna take. Okay, so name the name of the student. Now, when you're writing functions in Rust, you have to infer types, especially the return types. Okay, so this is the formula. This is the way you do it. And so we want to return OK message or error message. So we do if name. We want to just set a hard coded um, value here. And then we want to return OK. So OK is like a function. OK is a function, meaning the code you run or this particular block of code is correct or it executed properly. Yeah, it executed properly, not necessarily correct, but this part executed correctly and it has returned OK, right? So let's say homework is done. Homework is done. Now remember, in the last class, we always use semicolon to stop, to indicate the end of a statement, right? Or to indicate a statement, basically. So when we remove this, it means we are returning this OK. The same way you do return a Python or other languages, right? Yeah, of course, you also have that in Rust, but I think this is quite easy to just leave the semicolon out. And then else we want to return error. We want to report this error to the person that homework is not done. And remember again, we are returning this. So yeah. So we're going to call this function and pass the result into the variable result and do this. Okay, so here, what are we doing? We are taking the result and we are matching it with what is inside here. Either because basically we are expecting two outcomes, okay, or an error missing. So we are matching it here that if this is okay, then we want to print the message, right? But if this is an error, then we want to also print the message. So basically, you can say uh, if the goods are bad, right? Then we want to return it to the company. Pardon, that was for the error. Yeah. Okay, so if the goods are good, then we want to uh, put them in the store. And if the goods are bad, then we want to return it and ask for a refund, right? So these having a way out. So basically you can even call a function, if something happens, you can do something else, right, to fix that issue and stuff like that. So you should never uh deploy your code or put up a code without handling your errors because trust me, your app is gonna crash a couple million of times. Yeah, it's gonna be crazy. So with this, we're expecting other here. So we expect, okay, that homework is done. So let's run this. Come run the homework is done. Correct. Now let's see if we put We put Balablu Ulaba. All right, let's do this. Also, homework is not done. So this is an error message here. Homework is not done because this is not done. So basically, this is how to handle errors, and that's the use case basically. All right. So key takeaways: ownership keeps things safe, no double owners, no double spending. I mean, that makes the code more efficient. Yeah. Uh, so the raw syntax is strict but very powerful, and the control flow makes decisions, and loops error handling in Rust makes your code robust and safer on your server. Yeah. All right, so that's that for this class. Hope you enjoyed it. Go through the video and practice what we did, and make sure you study the resource that is sent into the developers mentorship group. Goodbye.